Hey guys, it's Safin, and today we're going to be talking about SSH as part of the Linux Visually series. So, let's just, before we kind of get into the technical part of this, let's describe a hypothetical scenario where SSH kind of relates to and it would make sense in the real world. So, imagine we have two friends, Alice and Bob. Alice and Bob want to pass some information along with each other, but they live on two different sides of the world. Now, how might they collaborate and communicate across the world without any other people seeing? What if Alice wants some confidential information from Bob? She doesn't want any spies to be able to see the communications that they might have. So what they did was they invented a magical tunnel that allows them to communicate freely, for Alice to ask Bob for information and for Bob to ask Alice, and for them to switch information as needed without other people seeing what's going on in between, because sensitive information, especially in a corporate scenario, must be kept secret. So it turns out, just like Alice and Bob might have this need, basically every single computer company or technology company requires the same functionality, whether they're transmitting company documents, emails, or just anything else that requires confidentiality between the two parties. Now, for this reason, the SSH protocol was created. SSH is a way for two kind of computers across the internet to connect with each other, and it's sort of a way to log in to another computer that's in a far distance away, not necessarily on your local network. It could even be across the world, it could be across the room from you, but regardless, you do not have to be on the same network for it, and it does so in a secure way. Now, the way it does this is using a form of encryption called asymmetric encryption. Now, I'm not going to go too deep into this, and I'd recommend for you to maybe look it up or find some cool YouTube videos online, because I'm sure there's lots of cool teachers that can explain this slightly better than I can. But I'll just briefly touch on it. The main idea of asymmetric encryption, well, rather, the idea of symmetric encryption is sort of like if you told your friend your phone password, you typed in some info on it, you locked it, and you gave it to them, and both of you kind of know the phone password, but it's just one password that's shared between you two, and it's used to unlock some information and lock some information when you turn off your phone. Now, asymmetric encryption is a little bit different because rather than having one passcode, you have, or one passcode or one key, which is what it's called in a cryptography setting, you would have two keys. Now, these key pairs are mathematically generated, and the algorithm is really complicated, so you don't really have to worry too much about it. But there's these two keys that are sort of meant to unlock documents that are locked by the other one. And what I mean by that is somebody that locks a document or encrypts a document is what we call with one of the keys can unlock it only if they have that other key in the key pair. One of these keys is meant to be public, meaning you would throw it out to anybody on the internet and they can find it. And the other one is meant to be private. And that one is the one you keep to yourself. So sort of the way it works is you say, hey guys, here's my public key. Feel free to encrypt any information with it, send it to me, and only I can decrypt it with my private key. And it's mathematically guaranteed to kind of work that way. And that's the basis of asymmetric encryption. Now, one thing that I mentioned kind of fast was that SSH was a protocol. Now, what really is a protocol? Let's talk about that right now. So there's a clear difference between a protocol and an implementation. You'll hear both of these words, whether you're studying Linux, Windows, any operating system, or even programming, you'll hear these two a lot. And the reason for that is a protocol is sort of what a theory-focused computer scientist would kind of do. That's kind of their job, and an implementation is more like somebody who actually codes something would handle. And as a computer scientist or Linux engineer or even Windows or whatever operating system you might be using, you'll hear both of these words tossed around frequently. Now, let's imagine you just bought a brand new fresh packet of Uno. Obviously, Uno has a few rules that are on the back of the deck, and pretty much everyone abides by at least most of those rules. But when you get into a game with your friends, it's really a game that's decided by the rules that you and your friends make up based off of the rules that are on the packet. And that's really similar to the difference between a protocol and an implementation. The protocol is the set of rules that's predefined, it's agreed upon by a set of experts that define how something should work, and the implementation is a real usage of that protocol or of those set of rules that kind of encompasses all those rules. It might have some slight modifications here or there, it might have some additions, might have some things that are slightly removed, but usually what we call correct implementations of a protocol have basically all the features and maybe some extras if they want to. In the case of SSH, SSH is a protocol. It's pretty much a document that outlines every single behavior that this whole operation between Alice and Bob should have programmatically, meaning it should outline everything that'll happen on the very lowest level of communication between these two computers. Now, as Linux security enthusiasts, that's not really important to us right now. If you'd like to do some more research on that, feel free to, because it's actually a really interesting topic on how they communicate and establish those communications using asymmetric encryption. But for now, we're kind of just going to stick with the surface level understanding so we can move on to what's really applicable for us. Now, like I said, SSH is a protocol, and a popular implementation of this protocol that's available on just about every single Linux system out there, and is also available for Windows, is called OpenSSH Server. Now, this is a implementation that defines how the server should kind of react based on a client's communication with a server, and that's sort of like if I were a client, meaning I want to access an SSH server, the OpenSSH server package would define all the behavior and implement all the behavior that needs to be implemented for me to make some communications over a secure tunnel. Now, I'd encourage you to all open up your Linux machines right now, so go ahead and pause the video and do that if you haven't already. I'm just going to hop over to my virtual machine right here, log in real quick, and I'm going to open my terminal. So the first thing that you're going to want to do is run a sudo apt install OpenSSH server. Now, I've already done this, so it won't actually install the package, but by default it's not installed. This will install the OpenSSH server that provides an implementation of the server side of the SSH protocol. Now, real quick, the first thing I want you to do is go to this file that's now present on your system after installing SSH, or rather OpenSSH server. So if you just gedit this file using any editor you might want to, I'm just going to pause. You can pause the video here and sort of do that. So hopefully you've done that by now. But if we look at this file, we'll notice a few things here, and I've sort of made the comment. We call lines that start with hashtags comments, meaning they're ignored. They're sort of like putting sticky notes in a book to remember some information. They're ignored by the program that processes all these instructions, and it's just something for humans to read. Now, the OpenSSH program reads this file, which we call a configuration file, and if you, it should be pretty obvious because you know English, so the config phrase in the file name refers to the fact that this is a configuration file, meaning it is used to configure the SSHD server. And when I say SSHD, that's sort of synonymous with OpenSSH server. SSHD is what we call a daemon that runs the OpenSSH server, and you can do some more research on that on your own time. But really, all it is a program that manages the OpenSSH server process. So if we head to this config file, we'll see a bunch of these different lines. A bunch of them are commented out actually, and that's sort of how it is on most recent versions of Ubuntu, defining just some preferences, sort of, you can say, for the SSHD program. Now, what I mean by preferences is you can actually customize the behavior of the SSHD service down to what port you want to run it on, or what SSH keys you want to use, the public and private keys you want to use on your server. You can customize whether you want to permit root login, enable the strict mode feature. And there's so many other preferences in this file that you can basically customize every single functionality of this program. And that's sort of how it works for just about every other service that you can install on Linux systems. They're meant to be super customizable just by editing a simple configuration file. Now, you'll notice that every single line, if we were to remove the comments, has a key value format. And what I mean by that is, think of a dictionary, for example. In your dictionary, if you open up to a random page, you'll notice that there's kind of two items associated with every word and their definition in the dictionary, and that is just that, the word and the definition. Meaning, if I were to look up, I don't know, box in the dictionary, its definition might be a cube surface that has some interesting properties, blah, blah, blah. It has a definition and it has a term. So you can think about it like a term and a definition. A key and a value in computer programming and in computer usage in general refers to a preference and a value for that preference defining how it should be saved. So port space 22 just means that this service should run on port 22, which is, or sorry, process should run on port 22, which is pretty self-explanatory. And all of them sort of look like this, where you have a key that's capitalized, and if you have multiple words, they're not separated by a space. They're just, for example, host key or listen address, would you put the first word capitalized and then capitalize the second word. So yeah, this is sort of the capitalization mechanism. There's a bunch of different ways to case. It's called casing, based on how you separate words, whether you want to use it underscore. Some people use underscores, some people use capital letters, but in the case of SSHD, we use this sort of format right here. The value is what's after the first space, and really what it refers to is the sort of definition for the term in this large dictionary, meaning the actual value that corresponds to the preference that you set will be after everything after the first space. So rekey limit in this case would be default none. So it's after the first space, you'll see everything else that corresponds to that preference. And finally, you might be wondering, well, why are all of these options commented out? Now, there's sort of two reasons for that. The first one is that usually in Linux config files, what you'll notice is that lines that are commented out by default, and by that I mean are commented out right when you open a clean image, are sort of just defaults, meaning that when the program comes installed, regardless of whether the user has configured a preference or not, meaning if they haven't configured a preference, it will default to that value because that is just the normal value that the program sort of runs with because it's considered normal that most people use it. So if you want to change a preference, you will have to uncomment the line, meaning you'll have to remove this hashtag right here. Now, this include statement is sort of sticking out from the rest because it seems to be the only line in this config file that is uncommented. And the reason for that is newer versions of Ubuntu have shipped a SSHD package that is sort of shifting in terms of configuration style. Now, what I mean by configuration style is that every single service has their own way to sort of define the format of these configuration files. Sometimes services like to put them in huge long configuration files, and other times services tend to split them up. So if we take a look at this directory that the configuration file specifies, if we hop over to etc SSH, I'm going to hop over to etc SSH and then go to sshd_config.d, pwd. This will show me the entire path, by the way, that I'm currently in, and I print all the files in here. Basically what's happening is every single file in this directory is being read so that it could be added to the SSH configuration. It's sort of like telling the program that, hey, go through every file in this directory and just insert it right where this include statement is. If we saw it back in the image real quick, there's actually no files in this directory, but if you were to configure the server, you could split up configuration. For example, you might want to put all configuration relating to the X11 server in one file, and maybe all configuration relating to authentication methods in another file. Now, you might not know what I just said, but I'll go over those two sort of directives in a minute. But what I mean by that is you can sort of split up different classes of directives, different directives that might correspond with each other, just so it's easier for you to organize, and they'll all be inserted into this file at the end. Now, In the scenario where you might be competing in a cybersecurity competition, or maybe you might be trying to do some hasty work on just to patch up a vulnerable server, a lot of the time what system administrators will do is just put preferences directly in this SSHD config file. Now, this is sort of considered a bad practice. It's really personal preference. But in the case of a large corporation, I would highly recommend splitting up files. But it's always good to look at this main configuration file, check through all the preferences, see if there's anything out of place, anything that should be secured, and configure files there. So now that we understand the comment, the key value structure, and include, we're going to go on to the resources that I would recommend that you look into to better configure the SSHD server. Now, obviously, like I discussed, SSHD is meant to be a secure tunnel between two parties, and we can customize the behavior sort of down to the wire. And really, there's so many ways that we can do that that there's a man page describing all of the functionality, and I would highly recommend you take a look at it. Now, if you just run man sshd config, and I've linked the man page right here if you can click on, if you want to click on it, if you don't have your image open right now. This man page contains a description of the program and just some information about how it works. Like I said, right here, configuration data is read from this file. Lines starting with a hashtag and empty lines are interpreted as comments, meaning they're ignored. And we see a list of all possible keywords, as in keys, and their possible values. Now, some of these preferences may be more important to you than others, but the three that I would recommend you look into, the first one is permit root login, and that's sort of self-explanatory. You really shouldn't have a extremely elevated user login through the secret tunnel because is a attack vector. What I mean by that is it's just a way for someone to get into your system that you really don't need, because no one's practically going to need to log in as the root user. And then just about everything that ends in the word authentication, whether that's pub key authentication, password authentication, challenge response authentication, there's so many different forms of authentication that you can use to authenticate using SSH, and I would highly recommend that you look into all of them. The one that I described to you earlier in this video was pub key authentication. There's also password authentication that just uses your password to log in, and that uses the PAM system. And there's actually a preference for that, use PAM. So if you're not sure how PAM works, go ahead and check out my PAM video. But yeah, that's one important one, because often the README of a cybersecurity competition may mention, or your employer may mention to you, that only specific authentication methods are to be allowed. Generally, pub key authentication is considered to be the most secure because companies can individually control which users are allowed to log in using which public keys. And then finally, X11, anything that starts with X11 you should check out, because X11 refers to the display system that manages the graphical user interface on your page. And if a graphical user interface is allowed, then that could be another possible attack vector. And it can just use up a lot of resources on a small server. So yeah, those three classes of directives I would recommend that you look at. And then obviously the resources I've linked here, it's very similar to the ones I linked for my PAM video. STIG and CIS benchmarks are always a really great place to start. And then another one that I thought was really cool and useful with some great preference settings is applied crypto hardening. These guys have a lot of options. Of course, I would recommend for you to test your entire configuration before you deploy it to a company scenario or put it in a cybersecurity competition. And one way you can do that is using the SSHD-T. This one, in the case of our clean install, there's no host keys, so it won't actually work. But in a actual cybersecurity competition round or in a company scenario, you will have host keys, and you will be able to run that command. Actually, in fact, I believe we do have host keys installed by default. Yeah, we do actually. The reason that this fails was because I didn't run it as super user. But yeah, if this sudo sshd-t command runs successfully, that means you're good. And if you have some garbage in sshd config, then it will let you know immediately, which is really useful when you're debugging, because it can point out, whoops, let me run that with sudo, it can point out errors before they even happen. So I would highly recommend you take a look at the sshd-t function, as it sort of tells you exactly where you need to look to fix items. So yeah, cool. Now that we got testing out of the way, the last thing that I wanted to do was a keys and perms demo. So let me hop back over to the Ubuntu machine, and for this section, of course, I'd highly recommend that you follow along. So I'm just going to hop over to Etsy SSH. And actually, I'm going to exit my root window. And first thing that I'm going to do is generate some public and private keys to log into the cpadmin user on my system. Now, remember how I said that these are mathematically generated? There's a nice program to do that for us. It's called SSH-keygen. Now, I would just press enter, and there we go. It's generated some public and private keys to use on our server. And if we actually go to the .ssh folder, which is generated automatically, we'll see two files, idrasa and idrasa.pub, where idrasa.pub corresponds to the public key that's used. And this is what it looks like, by the way. It's sort of a string of a bunch of characters, and this represents your secret key. Or rather, not your secret key, but your public key that you can distribute freely. And idrasa is your private key. Now, what I'm going to do here is actually I'm going to make a file called authorized keys and paste in my public key that I just copied from right here. What I just did was I created a file containing all the authorized public keys that should be able to log into my server to the cpadmin account. And if I just restart systemctl restart OpenSSH, SSHD. Oh, whoops, I should probably delete the garbage that I added to the file. Go ahead and do that real quick. What was it, line 19? Perfect. Whoops, let's run sshd-t again. And missing privilege separation directory. Whoops. Let's make sure we deleted all of that garbage. Pretty sure we did. Okay. So, what I'm going to do here is just apt install -- reinstall OpenSSH server. And this will just clear out all the preferences that we added. So now our file has been restored to default. Just some quick debugging tips. But our authorized keys and public-private keys should still exist. Now, if we just real quick check the status of our SSHD server, we'll see that it's currently running. And all I need to do is SSH cpadmin at localhost. Now, I'm just going to type yes, and boom. I just logged in using a public and private key pair. I wasn't asked for a password, but what happened was I automatically used this idrasa.pub file to sign into my own server using SSH because the public key is in the authorized keys file. So that's sort of just a simple demo of how I can use SSH to log into another system. In this case, this quote-unquote other system was really my own system, but I was able to log in using public and private key authentication. One thing, however, you need to be very careful of, and this should be sort of evident from what I've just done, is you need to make sure that this authorized keys file does not contain any public keys that are unauthorized. This would allow people who are not supposed to be able to access your SSH server log in. If they just stick their public key in here somehow, that could be a persistence mechanism, meaning a way for them to continually get in to your system and access your SSH server, which is not good because your company secrets or company information may be stored there. So be sure to check this authorized keys file in every single directory of users who do have access to your SSH server. Now, again, the last thing I wanted to do was go over perms real quick. And this is sort of just generic advice for every single service you'll configure on Linux. On Linux, there's basically everything, like I said, is a file. And the beauty of services is that you can configure them exactly how you want to using files. But one thing you need to be aware of, and this was pretty evident when I tried to edit the SSHD configuration file, is that this file right now to me as cpadmin is read-only. It can only be accessed by the root user. So if we do ls-l on this file, config, we'll see that it's owned by root and that the permissions are set as such so that the anyone else outside the root user or root group cannot write to this file. So I would be very careful of the permission set on your Etsy SSHD config file, on your authorized keys as well. Your authorized keys, especially your private key, should not be able to be read by any other user on the system. Your public key is alright, and of course the owner should be the user that owns the private key. So yeah, that's just a quick overview. In general, permissions should be pretty restrictive for service configuration files and service critical files. And what I mean by that is this would be the configuration and this would be critical, as in they are critical to the functionality of that service. Really be on the lookout for permissions that may be out of place. I would compare them with defaults. Just about anything you can do to make sure they are not available to users that should not be able to access them. So yeah, that's basically my broad overview of SSH. Hopefully you guys learned a bunch and you're able to do some work on configuring your own SSH server. Again, please look at these resources that I've linked on this presentation. I'll put the presentation link in the description. And yeah, just for future services, be aware of those permissions. And hopefully you guys understood a lot about SSH, pub key authentication, all that kind of good stuff. Let me know in the comments or wherever if you want me to go in depth on any parts of this video, like a little bit more. I'd be totally happy to do that. But yeah, thank you so much, guys. Hopefully that was helpful.